Hello everyone, welcome to StructPact. So today we are going to talk about recursion. What is recursion? Recursion is the process in which a function calls itself directly or indirectly multiple times until it comes to the base case condition where it stops the recursion. Or else we can tell that it's a function that calls itself repeatedly until a condition is satisfied. Simply it means that calling a function inside its body like the main function. It is the process of solving a problem by breaking it to smaller and simpler subproblems. So there are three types in a recursion: base case, recursive case and recursive function. So what is the base case? Base case is the simplest instance of the problem, or else we can say that it can be solved directly without further recursion. It is the condition that is used to terminate the recursion function. What is the recursive function? Recursive function means a function that calls itself. When it is called, it executes a set of instructions and then calls itself again with the same set of instructions but with smaller input. So this process continues until a base case is reached, which is the condition that stops the recursion, the recursive function. Recursive function contains recursive calls or different parameters such that at the end and it defines how to solve a larger problem in terms of smaller version of itself. So you can see here in the slide, this is the simplest way we can show what recursion is. So inside the function, there is the function itself which calls again and again repeatedly until a base case is reached. So now I'll explain recursion using a code so that you can get a clear idea what is recursion about. So here we can see that there is a function named int where it takes a parameter in which is a integer. So if n is equals to 1, it will return 1, or else it will return 1 plus function n minus 1, which means the function repeatedly executes by reducing 1 from each instance. So I'll show you how the recursion is done in two methods. So the first one, since recursion is mainly done using a stack, so the activation record in the recursion will be stored in a stack. We'll first see how it is done. So think this is the stack, and so here in the int main we are passing n3. So I have done a small So you can see here in the main function, we are passing the argument n, which is assigned 3. So we'll start from here. So in the main, n is 3. So n is 3. And when it executes the function n, it goes to here, and in function in if n minus is 1, which is not, it goes to the else part, return 1 plus function n minus 1, which means, so for the first function it will be function 3 function where n is 3 So the next one, n minus 1, which means 2. So here n minus 2 in function 2. So here it is function 2. So again it executes. So it comes back to here where function n is 2. Again go through this, and in else part it becomes function 1. So n becomes 1. So likewise this becomes this, and go to function 1. So this is the code. So now if n is 1, so again it goes to the beginning in function increase n, which means it's 1. If n is equal to 1, now it satisfies the condition. So now it satisfies the base condition, which means if n is equal to 1, it returns 1. So what we do now is we start to pop these stack items. So here in function 1, so it returns 1, which means that when we execute the function where the parameter is 1, it returns as 1. So which means it should return 1. So if we go here it returns 1, and for function 1 it returns 1. So the output is 2. So it returns 2. So this will be popped out. It will be, so it will be popped. So now the return is 2. So now it returns function 2, which means it will be popped out, which means now that we return 2, so here it is the function 2, function 2. So what is the return one? It is 2. So 1 plus 2 is 3. So the N2 stack will also be popped out. Now I think you got a clear understanding of what recursion means. So I'll use the step method. Now I'll show you how to do the other method. So here when int font is 3, it will return func 2. So when 2 and when int function is 2, it will return function 1. So when int function 1, when it's function 1, it will return 1 since it satisfies the base case. So now what we have to do is, when it returns 1, which means func1 gives us 1, which means it gives us. So we can see that when function parameter is 1, it returns 1, which means when function is 1 here, it will give us a 1. So which means it will give the total it will return 2. So it will, this is really good. So now if we call function 2, which means function 2 will return the previous value, which means 2. So here, when the function parameter is 2, it will give us 2, which means 1 plus 2 is 3. So this will also be executed. So now we have int function 3, which is our function in the main function. So when it's in function 2, it will return the value 3. It will return the value. So it's 3. So now it's the int function 3. So it will execute the function 2, which means it will give the previous value, which is 3. So output will be So I think you have got a clear understanding what recursion is. So now I'll explain another code. So here you can see that there is a function func which provides us a parameter n. If n is 1, it returns 1. It's same as the previous one. But here, if it is not 1, it will return 7 plus function n minus 2. So in the main, n is 4 and it will be executed when function is 4. So here So now function, since n is 4, func is 4 and it's not a 1. So return 7, which means return 7 plus return 7 plus function minus n minus 2, which means 2. So next, n will be 2. So func 2, it will return 7 plus func 2 minus 2 is 1. So return 7 plus 2 minus 2 is 0. So again, if we go to function 0, in function 0, since it equals to 0, it will return 1. So now we know function 0 returns 1, which means, so function 0 returns 1, which means it will give 1 here. So 7 plus 1 is 8. So int function 2 returns us 8. So if we go to the int function 4, in here function 2 gives us 8, and here 7 plus 8 means 15. So we get the output 50. So now I think you got the clear understanding of what recursion is. So now we'll talk about the recursion types. There are two main types, direct recursion and indirect recursion. In direct recursion, there are tail, head, linear, tree, nested, and non-tail. So first we'll talk about what is direct recursion. So direct recursion means that function is called directly again and again until a base condition is satisfied. So the previous code we have talked about belong to direct recursion. So in direct recursion there are some types as well. So what is tail recursion? Tail recursion, if a recursion function call itself in the function and after the recursion function it performs nothing, it is called as a tail function. It means that after the last thing done by the recursive call, it does not need to keep the record of previous data. So we'll try to understand what tail recursion means using an example. So here we can see that there is a function named smile. When n is 0, it returns. If else, you have to first print the n and it returns the smile n minus 1. And here in the main function, it gives 3 as the argument. So here, if we take a stack, and here the artifacts, main artifacture, so this is the main. So here void smile int is 3 if n equals n, which is not, else system out print smile n, which means if smile 3, smile is 3, which is smile 3 minus 1, which means 3 minus 1, it will return 2. So next the smile 2 is there. Here it is artifactor function 2. So it will print 2. Likewise, then we did a smile in minus 1, which is n is 2. So 1. Here 1. It will print 1. So we'll get the output as 3, 2 and 1. So after 1, it will give smile 0. So it satisfies the base condition, which means return, if equals 0, return. So it will return the printed output 3, 2, 1. That's the basic idea of what tail recursion means. So I'll explain it in another method as well. So here another example. Void simple int n. If n is equal, return 1. If else, return smile by minus n minus 1 and multiplied by 2. So the argument is given 4. So here if int simple is 4, n is not equal to 0, goes to the else part, return smile by n minus 1 and multiply smile n minus 2, it's not smile, simple, my bad. So int simple, so it will return simple, n minus 1 means 3, 4 minus 3 multiplied by 2. So then n becomes 3, int simple if 3, in the simple function the recursive function becomes simple n minus 1 is 2 multiplied by 2. So next int n becomes 2 n minus 1, which is 1 multiplied by, then next int simple becomes, so simple becomes 0 multiplied. So now n is 0. So if we call int simple 0, since it satisfies the base condition, it will return 1. So here what it will return. So now we have to read. So in int simple 0, it will return 1, which means in here simple 0, it will give us 1. So 1 multiplied by 2 is 2. So the simple 1 will return 2. So here in simple 2 it returns simple 1 multiplied by 2. So in simple 1 it has 2. So it will return 4. So in simple returns as 4. So here it will be 4 multiplied by 2, 8. So in simple will give us 8. So here simple 3, here it will be 8 multiplied by 2, 60. So the function will return the value 16 as the output. So our output is is 60. In tail it means we do not need to evaluate, where we have nothing to. So now we'll talk about head recursion. In head recursion, the first statement in the function is the recursive call, which means that the statement that is responsible for the recursive is the first statement, which is the recursive call. So we'll get to know about what is head recursion using an example. So here there is a code here where there is a function named simple, where we give an parameter int n. If n is equal to 0, it returns 1, else it should return simple function after dividing the n by 2, and it will print the and it will print the remaining of the function n by when divided by 2. So the argument given is 10. So we'll see how this works. So if we try to do it using the step method, so here it starts with simple 10. I'll just use this simple 10. So it goes to the else part. So it goes to the else part since it is not equal to 0. Return simple n divided by 2. So it will give us s divided by 10 means 5. And it will print n 2, which means 10 divided by 2, which is 5, and remainder is 0. So 0. So the next one. So now int is 5. So here is 5. So we will use step method to understand what head recursion means. So here here simple 10. Here is 10. Is 10, and it returns simple 2 since it is so since it isn't equal to 0, it gives us s 10 divided by 2, 5. So again it calls the simple function. It will give us 5 multiplied by, it will return us 1, and it goes back to the previous function, which means s2, where it will print n modulus 2, which means n 2 divided by 2, it will give us 0. then 5 modulo 2, which will be 1, and 10 modulo 2, which will give us 10. So our output will be 1 0 1 0. So you can see here that the first statement, it is responsible for the recursive code, which means the recursive code is the first statement in the function. So you can see here, recursive code is the first statement in the function. So that's it for the head recursion. Now we'll talk about linear recursion. So in linear recursion, the function call itself, the function call itself, as we previously discussed, the head recursion and the tail recursion are examples of linear recursion, which is the common way of doing a recursion. It provides us patterns for recursive functions, and the part of it exactly, and the general case in the linear recursion makes exactly one recursion call on a smaller input. So there are 4 parts in the linear recursion: base case condition, base case solution, arguments to recursive call, and general case solution. So we'll understand what linear recursion is in a code as well. So here you can see the power function, where a parameter named int exponent is passed. If the exponent is equal to 0, return 1, else there is a variable called subsolution where the function is recursed, where the recursive function is assigned, and it will return the value of subsolution multiplied by 2. So power, so in this it will give us power exponent minus 1, which is 3, and it will 3. So again power 3 is subsolution. So it doesn't go to the return function, again repeatedly executes the power function. Solution equals power minus power 2. Then if power is 2, solution, I just sub equals power 1, and power is 1, sub will give us power 0. So if power is 0, which means it reached the base case, so exponent is 0, it will return us 1. So now we have the value for the power function when we have the value for the power function when the exponent is 0. So this value goes to here, and in here it tells us that it returns 2 multiplied by subsolution. So here it goes 1 and subsolution is 2, so it will return us 2 multiplied by 1, 2. So for the power 1, it will give us 2. So it will be passed to the power 2, where the sub is 1 power when exponent is 1. So 2 multiplied by 2, 4. Likewise, here it will give us 4 multiplied by 8. And here, at the last function, substitution is assigned to power 3, which means 8. And it returns us 2 multiplied by substitution, which means 16. So when the power is 4, it will give us the output 16. It's the same as we discussed before. So I think you have got the idea of what linear recursion is. So we'll next move to the tree recursion. So now we'll talk about the tree recursion. Tree recursion means if the recursive function is calling itself more than one time, it is known as a tree recursion. It simply means that the recursive function calls itself more than one time at a time. More than one time at once. So we'll get idea of what tree recursion using an example. 4 plus ns minus n minus 2 means 3. So now first simple n minus 1 has to be executed. So if we execute S4, 0 not 1, 4 minus 1 is 3 plus S2 here. If S is 3, so if S3, S will simple n minus will give us 2 and plus S1. So same likewise here. S n minus 2 plus S1 here it will give us S minus 1 S minus 0 and here it will also give us S minus 1 and S minus 0. So here as well S minus 1 S minus 0. So now we have got the base. So now we have reached the base cases. so now what we have to do is for S1 it will return 1, for S10 S0 it will return 0, which means it will give us 1 here, and here S1 is 1 and it will give us 2 for both of this, which means S3 is 2. So here N2, here is 1, this is 0 and both are 1 and it will give us 1. So S4 means 3, S1 is 1, 0, so S2 means 1, S1 means 1, so S3 means 2. So S4 plus S3 means it will give us S5 means 5. So when in 5, which means that when simple is 5, it will give us the output as 5. So since n is 5 and here we print simple n when n is 5, so when n is 5 it's 5, so output will be 5. So that's the tree recursion. Now we'll move on to the nested recursion. So nested recursion means a function will call itself and the statement that is responsible for recursion is a function will call itself and the statement that is responsible for recursion is next, which simply means that there is a recursive call inside the parameter of the recursive call, which simply means function call in an argument. You can just say that recursion in recursion. So to understand what nested recursion is, we use Ackermann's function. Where it has two Ackermann function, where it has the functions which is a function having negative arguments only, which is used in this is used in higher mathematics. So we'll understand what nested function using a code as well. So we'll understand what nested recursion using an example as before. So here we can see there is a function named A where it gives two parameters m and n. So if m is 0, it should return n plus 1, and if m is greater than 0 and n is equal to 0, it should return a m minus 1 and the other parameter is 1. So here we can tell this is m and this is n, and the other if condition is if m is 0, it should return a m minus 1 and the other parameter is the same a function with another set of parameters m and n1, which means this is m and this whole thing is n, and inside n there this function a is called, and here this is m and this one is n. So here we can see that this is a nested function, since for n the recursive function is called again. So we can see here it is a nested function, since the a, which is the recursive function, is used as a parameter to return the a function. So you can see that there is a recursive function inside the parameter of the other recursion. So you can see that there is a recursive function inside the parameter of the recursive call. So if we here if a is 0, 0, output if 0, 0, if a is 0, which means m is 0 and n is 0. Here we have a condition, if m is 0, it should return if n plus 1, which means out n is 0, it will give us 1. And then if a is 0, 1, and m is 0, so it goes to this condition, return n plus 1, n is 1, which means it will give us 2. If a is 1, no. So here m is 1 and n is 0, so here m is greater than 0, which and n is equal to 0, so it will give us a m minus 1. So m minus, here m is 1, so m minus 1 is 0, and for n it will return 1. So here you can see that it's the same function as before with the same parameters. So here you can see that it gives us 2. So next is 1, 1, 1. So so m and n is both are greater than 0, so which means it will return a m minus 1 and a m n minus 1. So here a m minus 1 is, since m is 1, m minus 1 is 0, and here a, we got a, m is 1, since n minus 1, so n is 1, so n minus 1 is 0. So you can see that here this is the same function with the same parameters here, so it gives us 2 as well. So this will be a0 minus 2. So now we know in so now we get the answer A in the parameter 0, m is 0 and 2, n is 2. So as for our conditions, if m is 0, it should return n plus 1. So here m is 0, so it will give us n. So m is 0 and n is 2. So it will be 2 plus 1. So our output will be 3. So this is the argument function used to understand what nested recursion is. Simply what we need to understand is that this nested recursion is a function that is not only defined in terms of itself but used as one of the parameters as well. So now we'll talk about non-tailed recursion. It means if the recursive call is not the last thing done by the function, which means after the returning back, there is something left to evaluate. I hope you all remembered what tailed recursion is. It's the exact opposite of non-tailed recursion. In tailed recursion, we talked about how recursive call is the last thing to be evaluated. How the recursive call is the last thing to be executed in the function, but in non-tailed recursion, it has something to evaluate after returning back. So here we can see there is a function named int, and if n is 1, it should return 0. If not, return 1 plus fun n divided by 2. So here we'll draw the stack. So artifact main, which is the main. So here int is 8. Doesn't return 0 since it is not equal to 1. Return 1 plus fun n minus 2. So n divided by 2 means 8 divided by, so fun should be fun 4. Here fun 4. Here it will be 4 divided by 2. Fun 2, this will be fun 4, and here if function 1. So since it reaches the base case, it will return 0. So now it starts popping. So function 1 returns us 0. So function when fun is 2, this will be fun 1. So fun 1 gives us 0. So 1 plus 1, it will give us 1. So fun 1 will give us 1. So next one will be fun 2 here, and here it will be fun 4. So fun 2 returns us 1 plus 1. Here it returns us 2. So when fun n is 4, so when fun n is 8, this will be fun 4. So fun 4 gives us 2. So 1 plus 2 is 3. So when n is 8, it should print the output. So when fun 8 is called, it should give us the output. Give us the output as 3. If we remove this print function from here and put it to cut and to print fun. So here we can see that there is something to evaluate after the recursive call is executed. Move to the last recursion type, which is indirect recursion. What is indirect recursion? Indirect recursion means a function is called indirect recursion when it calls another function, and then that function calls the previous function directly or indirectly. So here we can see the example. Here there is a function in fun. Inside that function there is a function called func to be called, and in the func function, inside the func body, the fun function will be called. So you can see that the function fun will be repeatedly executed indirectly. So this does recursion but indirectly. So now we'll understand what indirect recursion means using an example. So here we can see that there is two functions named int odd and int even. So in int odd, there is a parameter is passed. If n is smaller than 10, it should print n plus 1 and n will be increased, and it will call even function. When in the even function, if the n is smaller than 10, it should minus 1 from the n and n will be increased, and it will call the odd function again. So we can see here that once the odd function is executed, even will be called. So this will be called. So when these instructions will be executed, again odd function will be called. Likewise each function is repeatedly executed until a base condition is satisfied indirectly. So as other recursive call is always in the recursive call is always in its body, but in indirect recursion it's always in the other function's body. So here if we try to get the output of this function, so here int n is 1, so odd. In the main, odd function is called, so odd n int is 1. So if n is smaller than 10, should print n plus 1, which means 2, and n plus here n plus 1 will be 2, and it will call. So Now n is 2. So now it will call even function. In the event that now n is 2, so n is more than 10, it will give us n minus 1, which is, so 2 minus 1, which means 1. So now n is 2, so n plus plus it will become 3. Now odd function will be called. So here it will be 3 smaller than 10, n plus 1, 4, n plus plus. Now since it's 3, it becomes 4. Even function is called. Here it becomes 4 smaller than 10, n minus 1, it will become 3, then n 4, so here it becomes 5. Likewise it will give us so 5 smaller than 10, n plus 1, which will be 6. So 5 plus n plus plus 4, 5 plus 1 means 6. So it's 6, calls the even function. So here it's 6 smaller than 10, n minus 1, 5, and again n plus 1, this will become 7. So here again calls the odd function. Here it will be 7, n will be 7 smaller than 10. Here n plus 1, which means 8, it will print 8, and n plus plus 1, which means 7 plus 1, which means 8. Again call even. Here it will become 8. Likewise, it will give us the output 2, 1, 3, 2, 1. Give us the output 2, 1, 4, 3, 6, 5, 8, 7, 10, and I hope you got the idea what indirect recursion means and how to implement the indirect recursion. So that's it for the types of recursions. So I think you got the idea of what recursion is and what are the types of recursion are. So that's it for today. Stay tuned for the next video. Until then, stay safe and have a good day.